Now for spheres, and we're going to look at the surface area and the volume of a sphere. Now, remember, when we talk about a sphere, it's similar to a circle. We still talk about the center of the sphere and the radius of the sphere, the diameter, everything's the same. We have chords and everything, except that, the sphere is three-dimensional. So we want to talk about first of all, the surface area. Now, when we talk about we're going to be referring to the radius of the sphere, and what that is, imagine if the sphere were cut with a plane, and the plane that cuts to make the biggest circle. See, you could cut the sphere up here, here, here. You could cut it with a plane, and you would get cross section. Well, the one that gives you the biggest cross section, we call that. It makes the great circle. You have a cross section of the great circle. That radius is what we're interested in. That's the radius of the sphere. And when we talk about the surface area, what we use is 4 pi r squared. So that's the surface area of a sphere. So if you have a sphere with a radius of 4, the surface area is going to be 4 pi times, instead of making it 4, let me make it 3 because we already got a 4 in there. It's going to be 4 pi times 3 squared. And that would be 36 pi square units. That would be the surface area. Now we want to look at the volume. Imagine, so let's think about a sphere and think about, you've got these, let's suppose that you kind of divide the sphere up this way. See, look at this thing. We've got these, okay? So each one of these, you can think of it as a pyramid, kind of a pyramid. But not exactly, because the base is like a sphere. In other words, it's like it's on the surface of the sphere, so it's kind of rounded. But let's just say we've got n of these things. See, here's a pyramid, here's a pyramid, 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 pyramid. We've got n of them. And let's suppose we make the whole sphere with these little pyramids. In other words, this sphere is full of them. So we can talk about the area of these pyramids and say, okay, that's kind of an approximation for the area of the sphere, if we just add up all those areas. Now remember, so here's one of them right here. Here's one of those pyramids. Now remember how it goes. For a pyramid, we say it's 1/3 base times the height. That's what the pyramid is. That's the area of the pyramid. And of course, in this case, the height would be the radius. So we've got 1/3 the base times the radius. Yeah. Now we've got n of those, right? So we've got n of them. That's the volume of one of them, but we got n of them. So let's see what we've got. We've got 1/3 times n b r. Okay, in 1/3 n b r. Now we're going to assume that n is a really big number, and in fact, you've got. Let's just think about n as millions and millions of these pyramids in there. Now, the more pyramids we have, the better the better the approximation for the area. So let's think about this NB, and let's just make a substitution. Let's suppose NB is the surface area. So it's 4 pi r squared times r. Now remember, we're saying there are a lot of these pyramids. There are so many that we just replace NB with 4 pi r squared. In other words, we just replace all of those, the base of the pyramid times n. We'll just replace that with the surface area. And if you do that, notice what you get. You get 4/3 pi r cubed. And this right here is the formula for the volume of a sphere. So if we've got a sphere, let's suppose the sphere has a radius of 5, then the volume is going to be 4/3 pi times 5 cubed. And that would be our volume right there. So that's what we want to use. So we got two things. We got the surface area, 4 pi r squared, and we've got the volume, which is 4/3 pi r cubed. Now let's just look at a way that we can use this volume. Let's suppose that we've got a cylinder of some metal, and we want to take that cylinder and melt it down and make a ball bearing out of it. In other words, let's suppose the material to make a ball bearing comes in this thing called a slug, let's say. And it's just a cylinder of metal that we're going to melt down and make into this ball bearing. Now, the ball bearing will have the same volume of that cylinder. Now, here's what I want to find out. I want to find out, with this much metal, represented by the slug, what will the radius of my ball bearing be? Well, let's find out what the volume of this cylinder is. The volume of the cylinder, I'll just say V sub C, is going to be this. It's going to be pi times 1 squared times 2. And that's going to be, what, 2 pi. So that right there, 2 pi cubic centimeters. Now, we want a ball bearing that's 4/3 pi r cubed. We want that to equal 2 pi. So the question is, okay, what does r need to be so that happens? See, we're just using this formula here, 4/3 pi r cubed. Well, let me solve for r. First of all, the pi's divide out, and the 2's also, this 2 will divide out, and we've got 2/3 r cubed equals 1. Now if I multiply, I get r cubed is equal to 3/2, and that would give me r is equal to the cube root of 3/2. So that's what the radius will end up being for this ball bearing that we make out of this slug.